All right, this first example I wanted to do because it doesn't exactly fit in with these formulas that we're given with the e of x. And we have a circle, and therefore we have formulas for a circle. So we have a circle of radius 1. Circle, the radius is 1. Okay. What percentage of points lie within a half a unit of the center? So if I went over a half right there, right, I'd have a smaller circle. Think of like a bullseye, right? And it's saying what percent out of all the points in the circle are within that half unit. So first thing we need is we need this area formula. Area is pi r squared. Next, percentage. So a percent is some sort of part over a whole, right? Like I got an 80% on a test. That means I got, 80 out of 100 total, right? Whether it's points or what, it doesn't matter. So we need parts over a whole, and I need this formula, pi r squared. So the part, the green part, right, is pi times 1/2 squared because the radius is 1/2. So the percent is pi times 1/2 squared. Okay, for the outer ring, the whole thing is pi times 1 squared, right? The radius is 1. So now, since division, these pi over pi is 1, right? 1/2 squared is 1/4, and 1 squared is 1, so divide by 1, I don't really need it. But it says what percentage, so 1/4 is 0.25, right, which is 25%. So 25% of the points lie within 1/2 unit of the center. Now, how is this, expected value? If we were to create this problem, let's say like a bullseye, right? If you score in here, you get 2 points, anywhere else you get 1. Then I could use these probabilities, right? The percentage, I could use the probability of landing within there multiplied by the outcome, the 2, and then add the probability of the outer ring with that 1 and find an expected value. Okay, this is kind of like setting up an expected value problem. So there's A. B. This worded kind of weird for this class, but that's okay. Let C be a constant between 0 and 1. What percentage of points lie within C units? Well, if it's within 1/2, we put it here, right? That's our radius. So for C, however far this comes out, I don't know. We're just going to call that radius a C, but the rest is the same. We have pi, go back to blue, we have pi times C squared over pi times 1 squared. So the pi's still cancel, right? C squared over 1 squared is C squared. Now, I don't know, how do I write C squared as a percent? So we got to kind of think of this one here. 1/4 was 0.25, like we said, right? But then what did we do? We multiplied that by 100%, right? Which is 1. 100% is 1. And that's how we got 25%. So C squared times 100% is just 100 C squared percent, right? I mean, we could have left it C squared times 100%. Either way. So whatever length they give you, however far away from the center, you're just going to square that and times it by 100%. Okay, moving on to this word problem. So something, a bit more realistic in the business world. So I'm going to kind of highlight here. The anticipated profit of 100,000 if the nightly temperatures remain mild. The weather indicates a 25% chance they'll drop below freezing. If it does freeze, it'll destroy 40% of the crop, so therefore reduce it to the profit to 60,000. Okay. They can protect the citrus against freezing, but it would cost them 5,000. Should they spend the 5,000, it's going to cost, it'll cut into their profit, or should they go ahead and gamble on the weather, make the full 100, not spend that 5? But if it fails, they only make 60, right? Oh darn, only 60. So what should they do? E of x, expected value. All right, let's take a look here. We have 25% chance that it'll drop below freezing, which means we have a 75% chance that it won't, right? So to make that full $100,000, that's the outcome. The probability is 75% that everything's going to be fine. Okay. And I did kind of jump the gun as I read this in my head, but compute E of x, where x is the profit the grower will get if he does nothing. Okay. Now, there's a 25%, it's ruined. So 25%. Remember, these probabilities should always add up to 100 as well. Otherwise, you're missing something. 75% chance, we're good, make 100. 25% chance, I drop down to 60. Right, that's that outcome. So multiplying that out, let's see, 75% of that is 75,000. And then a fourth of that is 15,000. So we get $90,000 is the expected outcome if he does nothing, right? That's important to note there. If we do nothing, we expect $90,000 profit. No measures were taken. So, should he? Should he go ahead and protect him? Well, if I expect 90, right? But if I spend 5,000, I'm going to get 95 only, right? It's only going to cut into my profit 5,000. That's higher. So, yes, he should spend the 5,000. Right? Again, because that yields 95,000. The expected value of doing nothing is 90. This is greater, so go ahead and protect